right, today we're going to look at something called the interval notation with inequalities. We want to be able to solve inequalities and write the solution in interval notation. Recall some of our inequality symbols here. We got less than, we have greater than. Then if you have that line underneath that, it means less than or equal to in both cases. So having that equals to line underneath. How do you write an interval notation? A bracket, indicated by that symbol, means that value is included in the answer. This is very much like closed dots on a number line. So we've seen inequalities written like this before. If we were to graph out this inequality, it would be our numbers here between -1 and 2. So we would have a closed-in dot at 2 because we got or equals 2. We'd have a closed-in dot at -1. It's numbers less than 2, greater than -1, so everything in between. In boundary or interval notation, we would write the same inequality using the two numbers, -1 and 2. You put a comma in between to indicate it's spanning from -1 and -2. Then if you want to include the numbers at the endpoints, you bracket them in. So this would be, these two notations mean the exact same thing. All right, a parentheses means that the value is not included. This is like an open dot on a number line. So again, if we were to graph out this inequality here, it's the numbers from -6 to -10, not including those endpoints. So if we were to graph this one, it would look like this. The numbers less than -6, greater than -10 would look like that. In boundary notation or interval notation, again, we'd include our two numbers here that we're spanning in between -10 and -6. Since we don't want to count the endpoints here, we'd use parentheses. If an answer extends indefinitely or extends to infinitely in one direction with our inequality, going towards either -infinity or infinity. So when we go out forever, we want to use one of those two, in -infinity or infinity. Infinity means we go forever to the right in the positive direction on the number line. -infinity goes forever to the left, to the negative side on the number line. So let's see if we can write or graph both of these and then write the notation for them. So here, it would be all the numbers less than 2 here. So if we're looking at our number line like this, all the numbers less than 2, we would graph like that with an arrow extending to the left there. In boundary notation or interval notation, we would write this as 2 being the biggest thing. -infinity is the smaller thing here because it's going to the left. Again, put our comma in between. We're not counting 2, so we'd use a parentheses. And then with infinity and -infinity, we always use parentheses here. So it would be like this, since it's not a closed number. B, same thing. If we were to graph this one on a number line, it would look like this. We'd have open circle at -8 because we're not counting that point. It's the numbers greater than, so it'd be going that way. If we were writing this one in that interval notation, it would be the smallest thing's -8, not counting it, so we'd use parentheses. And we keep getting bigger, so we'd use +infinity. Again, parentheses always with infinity or -infinity because it's not a closed location. All right, so now for these ones, they want us to express each interval in terms of the inequalities and then graph them. So they want us to go the opposite way here. This first one, would be all the numbers from 4 to 8. So if we were going to write that in the inequality notation, we'd have 4 and 8. It's the numbers less than 8, greater than 4. Parentheses indicate we are not including either of the two endpoints, so that would be our inequality. If we are going to graph that, 4, it would look something like this, where it's the numbers in between, not counting the endpoints. For B, the numbers between -2 and 3, so -2 and 3, less than 3, greater than -2. In this one, don't want to include 3. We see a bracket at -2 though, so we do want to include -2, so that would be the inequality. If we were to graph that one, remember brackets are similar to closed in points, so we would close the one at -2, open at 3, everything in between. C, -1 is the smallest thing, and we're going all the numbers bigger than that. So here, if we want all the numbers bigger than -1, we would write it like that, and we're not including -1 because of the parentheses there. On a graph, that would look something like this, where we got -1, open circle, all the numbers bigger, so arrow going to the right. These ones express the interval in terms of inequalities again, and then graphs the same as we were doing. I want you to pause and try these ones out on your own. All right, see how you did here? On that first one, they're both bracketed, and so you want to make sure you have the equals to with your inequality symbols, and then because we're including the points, you should have closed in circles at both -4 and 6. The next one, see how it has -infinity, so we're heading to the negative direction, so it'd be all the numbers less than or equal to 3, because again we have a bracket, so closed point heading to the left. The last one, we're going towards infinity, so our graph's going to be going to the right there, -1 being the smallest number, open circle on this one because we're not including the point. All right, the next one's here now. Again, they want us to graph, but this time write it in the interval or boundary notation. So the first one, x is less than -4. If we're heading less than, that means we're going towards -infinity, with -4 being our biggest point. We don't want to include -4 here, so a parenthesis. Graphing that out, wherever we got -4 on here, we should have open circle, because we're not counting -4, going left because it's the numbers less than. B, numbers greater than -5. So here -5 is going to be the smallest thing, and we're getting bigger, so we're going to positive infinity. Always parentheses with positive or negative infinity. Again, we don't want to count the point here, so parentheses on both sides. Graph on this one would look something like this, where we got open circle at -5. We're not counting that, and we're going right because we're getting bigger. C and D here, they want the interval notation for both of these two. Here we're spanning between two numbers, so then again we separate those numbers with a parentheses, or sorry, with a comma, and then parentheses on the -5 because we're not including the point. The 1/4 we are, so we want to make sure we have a bracket on that side. Graphing this one, you would have -5. Uh, 1/4 is going to be somewhere between 1 and 2 on here, so open circle at -5. Probably about 1/4 of the way would be maybe like right here, a closed in circle there, connecting them. If you're not maybe right on a line on your graph, maybe include that the label that this is at 1/4 here for that. The next one, again, we're spanning between -7 and -5 because we're less than -5, greater than -7. Here, parentheses on both because we're not including them. Graph on this one would be numbers between those two, so looking something like this. Open circles, we're not including the numbers. All right, union. If you have a union, we talked about this before, it consists of the numbers in either one interval or the other, or both. So when you have a union, it's joining together the two groups of numbers. For A, if we have the union of 1 to 3 and 2 to 7, what would that be? Well, let's graph them both out on the same line and then see if we can write this another way. So 1, the first one's all the numbers between 1 and 3, not including the endpoint, so that would be these numbers. 2 to 7, not including either point, would be this one. So how could, if we joined those together, what would the graph look like? Well, the graph would look, we'd start at 1, we'd go here all the way to 3. Now at 3, we don't have a point here, but we do have a point here, so we can include that. So it looks like the union of these would include all the points from 1 to 7. So the union of these two intervals would be 1 to 7, including all the points in between, but not the endpoints. Let's try B. If we union these two groups, let's again graph them both on the same one. Okay, so the first one's all the points from -4 to 5, not including either of those 2 points. The second one is -2, including that point, and all the points out to infinity there. So what would be joining those together? Well, -4, not including that's the smallest thing. We have all these numbers, 2's included and -2's included in both here. We keep going. All right, now we hit 5. There's no point at 5 on the first graph, but there is a point up here at 5 here. Plus we got all those points going to the right. So it looks like we can write this one as a union by just saying it's all the numbers from -4 to infinity, not including -4 because neither graph had a point at -4. So if you union, you try to write them together into a simpler set if possible. Intersection, if you have intersection, that consists of the numbers that have to be in both intervals. So if you have an intersection, it has to include both. Our graphs of these we had from before. So I'm just going to copy these. Is that right? So on this one, what we're looking at here is we had those two graphs before. Now with intersection, we're looking what do they have in common, not what joining both together. So on this one, where's the overlap happen? With this, you can see overlaps happening right in here. So if we're doing intersection, we want to describe those points in both. So the points that are in both, 2, it looks like where we start here. Now 2 is included in this red graph from 1 to 3. It's not included in the green one. So if it's not included in both, we can't count -2 in our union here. So our union would be 2, not including that point. All these points are in common here and here. Once we hit 3 though, 3 is not included in that red graph, even though it's included in the green one. So we wouldn't want to include 3 either. So it's just the points in between 2 and 3 that are included in both. So that would be the intersection of those two. On the second graph, we're looking here, where's our overlap happening on this one? Looks like overlap's happening in here. So on this one, for our intersection, we have -2 looking like the first point. Now both sets include that, so we can include -2 because both sets have it. All the numbers in between here are good. At negative or +5, that's where we run out of this graph. So we can't include any points beyond that. So -2 to 5, not including it because the red graph did not include it even though the green did. So that would be the intersection of those two. So intersections, points included in both. All right, last thing we're looking at here, they want us to look at these graphs and come up with interval notation with them. So this is probably the easiest thing we've done so far. We already got the graph, we just got to interpret it. This is looking like it's all the points less than or equal to 5. So in our interval notation, since the smallest thing it's going towards -infinity, we got to write that first because that's the smaller thing that's smaller than 5. And then with the notation, always parentheses with either positive or -infinity. We are including 5, so bracket on this side. With the second one there, now this is all the numbers greater than -1. Here, since -1 is the smallest thing, we write that first. Infinity is where it's going out to. Always parentheses with infinity or -infinity. We're not including -1, so it would be parentheses. B, the first graph there, all the numbers between -10 and -8, not including either point, so that would be the inequality if we were writing that in the interval notation. Same two numbers separated by a comma, parenthesis on both because we're not including either number. The next graph on B is again between. Now you got to be careful on this one. They're going by 2's here, so in between that would be at -11 and that would be at -5 in between there. So these would be all the points between -11 and -5, including both because we got closed circle there. So on this one, when we're writing these separated by the comma, since we're including both, bracket on both for the interval notation there. C, on this one, a little bit harder now because you got graphs on both sides. So let's try to first write it in like an inequality. The one on the left here is all the points less than -5. Or we also have the points over here that the points are greater than 4. How do we write that in the interval notation? Well, since we got two groups of numbers, we're going to have to union together two of these intervals. So the first one, the smallest thing's -infinity to -5. We're not including it, so parenthesis. Union with the group of numbers from 4 to infinity, not including 4. So that would be how we'd write that one in the interval notation. All right, your turn. Try these ones out, and then you can check when you're done. All right, check them out. See, I did. Since we're got -infinity here, where all the numbers less than or equal to -8, because we got a bracket there graphed out, you should have -8 with a closed circle heading left. On the next one, it's all the numbers between 4 and 11, including 4, so we should have a bracket on 4, parentheses on 11. Graphing that, you should have a closed one at 4, open at -11, all the points shaded in between. The last one, you got to notice this is intersection. That's the numbers shared by both groups. So if you graph these out, we got the points from -5 to 0 and then -2 to 8. Our overlaps happening right in here. So that's the interval from -2 to 0, including both endpoints, since both graphs have values there, we can include both those two endpoints. So hopefully you did okay on those.